Here we're given the equation of a curve C, so y in terms of x, and we're asked to find the equation of the normal at the point x equals 4. Now, the normal is simply a line that's perpendicular to the tangent at that point. So we're going to need to find the gradient of the tangent, so we're going to need to differentiate y. So we'll need a plan. First step in the plan is to simplify y, to get rid of the fraction, to get rid of the surds, to get rid of these powers. Next step is to differentiate, find dy by dx. Third step is to substitute x equals 4 to find dy by dx. Then find the negative reciprocal of that to find the gradient of the normal. And then we're going to need to find the actual point, x1, y1. So we're going to substitute x equals 4 into the original equation to find y, or y1. The final step, we find the equation of the line. So let's start by trying to simplify y. So let me first simplify the numerator by expanding those brackets. So 3x plus 5 squared simplifies to 9x squared plus 30x plus 25. And we subtract from that 9 over 2x cubed. And in the denominator, we have x to the power 1/2. Now what we can do is separate each of these terms and divide them by the same denominator. So y can be rewritten as 9x squared over x to the power 1/2 plus 30x over x to the power 1/2 plus 25 Now, when we divide, we subtract powers. So each of these powers we subtract, and we can imagine that here we're going to have an x to the power 0, and here we have x to the power 1. So now we can write y as 9x to the power 3 over 2. So I subtracted 2 minus 1 over 2 plus 30x to the power 1/2 plus 25x to the minus 1/2 minus 9 over 2x to the power 5 over 2. So that's y. What we now want to do is to find dy by dx. So we can now write dy by dx equals, now we're going to differentiate each term, so that involves multiplying the power by the coefficient and then subtracting 1, multiplying the power by the coefficient and subtracting 1, and so on. So dy by dx will be 27 over 2x to the power 1/2 plus 15x to the power minus 1/2 minus 25 over 2x to the minus 3 over 2 minus 45 over 4x to the minus 7 over 2. So that's dy by dx. It's quite a large expression, but what we want is to find the value of dy by dx when x equals 4. So we substitute 4 into each of those terms to give you dy by dx at the point x equals 4. So if you put that into your calculator, you end up with quite a large number. So that's the gradient of the tangent. So that is dy by dx at the point where x equals 4. But what we want is the gradient of the normal, because the question mentions finding the normal to C. So the gradient of the normal would be the negative reciprocal of dy by dx. So it would be negative 512 divided by 30643. So now we have the gradient of the normal. We proceed to find the value of y at x equals 4. So to do that, we would substitute x equals 4 in our original expression. So x here is replaced with the number 4. So we can find y as 3 times 4 plus 5 squared, 2 times 4 cubed, divided by the square root of 4. And if you put that in your calculator, that gives you a half. So now we know that the intersection point, or the point at which the normal cuts the curve, is 4 half, because this half is your y and this 4 is your x. So the last step is to write the equation of the straight line. And the equation of any straight line can be written as y minus y1 equals m times x minus x1. And x1 is that 4, and y1 is that half, and m is the value which we found earlier, which was 512 over 30643, with a negative sign. So we can say y minus 1 over 2 equals minus 512 over 30643 into x minus 4. And that's the equation of your straight line. But you want to tidy this up. You want to get rid of this denominator here and probably this denominator here. So I suggest you multiply both sides by 2 and by 30643. So that will give you 61286 y minus 30643 equals minus minus 1024 times x plus 4096. And we can tidy that up by bringing the terms all to the left side. And that will give you 61286y plus 1024 minus 34739 equals 0. And that is the equation of your normal. So it's good to express your equations in a form where you have integer coefficients and it's equal to 0. So this is the way in which your final answer should be expressed. So this is how we approach the question with a plan, by simplifying y, then differentiating, substituting x, and then finding the equation of the gradient of the normal. Then we needed to resubstitute x back into the equation to find y1. So we had x1, y1, and m, and then we rewrote we wrote out the equation of the normal.